The fundamental theorem of algebra says the total number of zeros equals the degree. So that is not new to us. It's just the idea that that is called the fundamental theorem of algebra. That number, that degree, includes your real and imaginary. So remember, only the real ones show up as x-intercepts. So you might see that your graph has 3 x-intercepts, but if it has 2 imaginary solutions, it really has a higher degree, degree 5. So degree does not always mean that's the number of times it's going to cross the x-axis. And we also talked about earlier in the chapter like multiplicity, like how you can bounce on the axis and have even multiplicities. So you might not even have as many x-intercepts as degrees if you have some multiplicities as well. This is just really nice to know.
At this time, we need the following groups to go to the main gym for pictures: College Possible, Education Academy, Esports, and Gaming Club. Again, that's College Possible, Education Academy, Esports, and Gaming Club.
The fundamental theorem of algebra is just really nice to know because the directions on your homework and the quiz and the test, they're going to say find all the zeros. Well, wouldn't it be nice for you to know how many answers you should have, if you're missing one? Okay. So you'll know you're done with your problem when you have all the zeros. Okay, when you have as many zeros as you have degree. And don't forget to include multiplicity in that list. Okay. And so then we're going to do just like we've been doing before, finding zeros. Well, you have 2 ways to do that in polynomials. You can factor. Okay, so think back and maybe always have out that green sheet with the factoring graphic organizer. You have GCFs, greatest common factors. You have difference of squares. You have sum and difference of cubes. You have factor by grouping. You have trinomial guess and check. Okay, so you have a lot of options for factoring, right? Always a good idea to check and see if you can factor first. I like to factor. But not everything will factor. So when everything doesn't factor, you use rational root theorem. So that's your plus or minus P over Q. Instead of checking any number that you just randomly choose, pick a number from this list, ratio of constant over ratio or factors of your constant over factors of your leading coefficient, because if a rational zero exists, it is on that list. You can also use it with yesterday's work, so I'm going to model that for you. I'm going to call it Descartes' ROS for rule of signs. So you can make this list plus or minus P over Q, and then sometimes Descartes can make your list even smaller. So you use that list, okay, and then you do synthetic guess and check until you get to that happy zero. So that's like a combination of lots of tools we've done. We've learned Descartes, we've learned rational root theorem, we've learned synthetic. We know the idea of it's a factor if we get a zero. So we're putting all that stuff together, so we're not really factoring it, but we're checking for zeros with polynomial division. So those are ways that you can solve polynomials. And then we'll do some examples. If you're just coming back to us and you haven't got all this notes, if we finish our examples, I'll put this back up, and this will also be online. If you need to go grab it from the video, you can. Okay, let's find all the zeros of this polynomial. F of x equals 8x cubed minus 46x squared plus 59x minus 12. Okay, well, I would always check, like, okay, that polynomial has 4 terms. Would it factor by grouping? Probably not, right? What I could take out of 8x cubed and minus 46, like I could take out a 2, so I'd have like a 4x minus 23. That's not going to be the same of what I could take out of 59 and 12, right? Probably 59 is prime is my guess. So doesn't factor. Okay. So that means I'm going to use method 2, which is make my list of plus or minus p over q's. Okay, possible zeros. My p's are factors of my constant in the back. So we've done 12 quite a bit. Factors of 12 are 1, 2, 3, 4, 6, and 12. Those are going to be my p values. Over factors of my leading coefficient. My leading coefficient is 8 over here. So that would be factors of 8 are 1, 2, 4, and 8. So then I just do all the p's over all the q's, okay, and only write down new answers, like new possible zeros. So all of these red numbers, 1, 2, 3, 4, 6, 12, over 1 are just going to be themselves. So we'll have on the list plus or minus 1, 2, 3, 4, 6, 12. Right? And then I double check, I take all the red numbers, 1, 2, 3, 4, 6, 12, and I put them over the next q, which is 2. 1 over 2 is new. 2 over 2 is 1, don't need to write it down. 3 over 2 is new. 4 over 2 is 2, 6 over 2 is 3, 12 over 2 is 6. Those are already on the list, right? So only the odd ones over 2 produce new solutions. And then I take all the red numbers and I put them over 4. 1 over 4 is new. 2 over 4 is 1/2. That's already on the list. 3 over 4 is new. I don't have 3/4. 4 over 4 is already on the list. 6 over 4 is 3/2, already on the list. 12 over 4, 3 is already on the list. Okay, so again, only the odd ones made new ones. And then I take all of these and I put them over 8. So we'll also have 1/8 and 3/8. 2/8, 4/8, 6/8, 12/8, those are already on the list. So I don't need to rewrite them. Okay, well that's kind of a long list, right? I got what? 1, 2, 3, 4, 5, 6, 9, 12 positive and 12 negative. So that's 24 numbers I could check with synthetic. Ugh, that's still a lot. Better than infinity, okay, but still a lot. So I'm going to do Descartes. Okay, so if I look at the positives, I'm looking at f of x. Jayla, you got something I've done wrong?
No, I just have a question.
Yeah.
So when you're making the list, would 6/4 be one?
6/4 reduces to 3/2, which is already on the list.
Oh, yeah.
In all of these, only the odd numbers over those values will actually make new zeros. Yeah. Okay, so we're doing Descartes' rule of signs. Count the sign changes in f of x. It goes from positive to negative, so there's 1. Negative to positive, there's 2. And positive to negative, so there's 3. I'm not going to make the whole chart this time. I'm just going to say, do you agree there were 3 sign changes, so there could be 3 or 1 positive zeros? Okay. What that means for me is from this list of possible zeros, these are just the rational zeros, I'm thinking 3 of these or 1 of these positive ones will work. Like I will get a 0 with synthetic. Okay, so I'm thinking, okay, I want to check some positives.
Could the 3, if, say hypothetically there's 3, even though I don't know if there is or not, could one of those be the same value as if it were 1? So, like, could the values 1, 2, and 4 be it for 3, but, like, 2 be it for 1?
Yes.
Okay.
But it won't be both. It'll be one or the other in the end when you solve it. Okay. Okay, now we're going to do the negatives. Okay, so we need f of negative x. I'm just going to write that down right below. Let's see, that'll be negative 8x cubed, because when you raise a negative x to an odd number, it'll change signs. This will stay minus 46x squared. And then this will be minus 59x, and then minus 12. What do you notice about sign changes in f of negative x? There are 0 of them. Okay. No sign change. Okay. So that means how many negative zeros did you have? 0. Okay. Do not check negative numbers from this list. They will not work. So here Descartes is helping us. Remember, I counted up all my possible zeros right there and said there's like 24 of them. That's a lot of numbers to check. But now Descartes told me the 0 won't be a solution. Or the negative zeros won't be a solution. So don't check any of the negatives. Now I'm down to 12. That seems more reasonable. Okay, can we split some of the work? So let's see. I'm going to put... Brianna, you'll be like with this pod. Why don't you guys check positive 1 with synthetic? Will you guys check positive 2? You guys check positive 3? You guys check positive 4? You guys check positive 6? So go ahead and check those with synthetic. So we'll do a little group sourcing. Set up your synthetic box. And I assigned you guys only positive values to check. Let's see, I'm not missing any terms, so I can just drop in my coefficients. Okay. Let me know if you get a result. You guys are saying, make sure you talk with your group so that I can get some feedback. And we're just starting, the first example. Okay, so work together and double check out. You still calculating? You say no? You guys had 3? 3 is a no. Oh, not 6? Okay, make sure you talk with your group so that we can reduce the amount of work we're doing up here on the board.
It is not 2.
It is not 2. My 1s and my 4s. We don't think it's 1. Jayla thinks it's 4.
Yeah, it's 4.
Oh, okay, and her group is now starting to agree. So let's put 4 out there so we're working together. Okay, so I call that crowdsourcing. Okay. All right, so we'll put the 4 out there. And then we'll add down to get 8. Remember that leading coefficient always just drops to the bottom because there's nothing to add it with. And then 8 times 4 is 32. Let's see, negative 46 plus 32, that would be a negative 14. And then negative 14 times 4 is going to be negative 56, which is 3, which is 12. Yay! We found it, right? So we're trying to find all the zeros. We have one of the zeros is 4. Okay. And that goes along with what we said with Descartes. There would be no negative zeros, so I had you only check the positives. We've now found one positive, so we know at least one exists. Descartes is saying maybe there's 2 more positive real zeros, but we don't really know, right? So like what we could do is we could continue doing synthetic guess and check, but if you kind of look at where we're at, what do we have left to check from our list of possible zeros? Because we checked 1, 2, 3, 6. Those didn't work. We could check 12, and then we're getting into all of our fractions, which you can check with synthetic. But I would say this. So the original problem that we're trying to work with is an x cubed, right? We divided once, found that it worked, so we got a 0 right there. This is x squared. So I usually take this, 8x squared minus 14x plus 3. If it's quadratic right there, I just write out the quadratic and I either try to factor a quadratic formula.
At this time, we need the following groups to go to the main gym for pictures. Global Support Club, Fellowship of Christian Athletes, Circle of Friends, PLUS, Starlight Unified Cheer, Unified Bowling, and Titan Brew. Again, that's Global Support Club, Fellowship of Christian Athletes, Circle of Friends, PLUS, Starlight Unified Cheer, Unified Bowling, and Titan Brew.
Okay, so what we don't know is like if, because this is a cubic polynomial, if there's only one positive real zero and there's 0 negative real zeros, the other 2 might be imaginary. So like if I could check all those fractions on that list and if they're imaginary zeros, I would have done all that work for nothing, right? Because I would have found they didn't work. So I like to always go to the quadratic and write the quadratic down because now I can try to factor or I can quadratic formula. I'm thinking this one might factor. I think this one does factor, so just to like kind of help with guess and check, I'm going to try to factor it. Okay, well, 8x squared is a little bit tricky for us because there's lots of ways to get 8x squared, right? 8x times x, 4x times 2x. So I'm going to pause that one momentarily. I'm going to go to this last number. There's only one way to get 3, right? 1 times 3. So I'm going to put in a 1 and a 3. And then it has to be a positive 3, so they have to be the same signs. But I noticed that my middle term is negative, so they must have both been negatives. So it'd be like negative 1 times negative 3 would make a positive 3. But then it'll give me the negative values for my middle term. Okay. So now what I'm doing is I'm guessing and checking in these first positions. Like, is it 8x and 1x? Or is it 4x and 2x? Or I could switch them around. So I can kind of think about it like, okay, if I put an 8x and a 1x in there, I'll get 24 and 1. That's not giving me 14, right? I can switch it around. I can do a 1x and an 8x, and that'll give me a 3x and an 8x, but that won't give me 14. That'll give me negative 11. So now I'm going to try like 4x and 2x. That'll be 12 and 2. That going to give me 14? Yeah. So if I put a 4x and a 2x in there, when I check it, 4x times 2x is 8x squared. 4x times negative 3 is negative 12x. Negative 1 times 2x is negative 2x, so that totals out to negative 14x, and negative 1 times negative 3 is positive 3. So I was guessing and checking. Okay, I was trying possible answers. They won't always work. You're really kind of like checking your outside and inside terms right there. Like, will they work? Okay, so then if that's factored, I could set my two factors equal to 0. And that would be like 4x equals 1, so x equals 1/4. 2x equals 3, so x equals 3/2. So I can add those to my list. 1/4 and 3/2. I have 3 zeros. It was a cubic function, so I got them all, right? And in this case, it happened like if I go back up to my Descartes, it just so happened that all of these numbers are positive real zeros. Like they show up to the right of the y-axis. They're in the positive axis. So there were 3 positive, 0 negatives, and then that would mean because my degree is 3 that there are 0 imaginaries. If I wanted to graph that polynomial, I could plot my x-intercept at 1/4, my x-intercept at 3/2, my x-intercept at 4. Let's see, I think my y-intercept is a -12, so somewhere down here. And I have a positive LC with an odd degree, so the right side rises and the left side falls. So it must look something like this. It all kind of comes together. Rather than do another example, I would like to give you just 10 minutes to get started on one from the homework. That way you can be actively doing it, maybe getting some guess and checks done with your group or with the class. We can crowdsource if you want, but you'll be like actively working out that problem and getting one of your homeworks done. Okay, so we can always do another example tomorrow at the beginning of class if we want. But there's 5 problems on your homework tonight.